Hi viewers, today we're working on calculation on instantaneous velocity, instantaneous acceleration, average velocity and average acceleration. Now alongside all this, we're going to be working also on instantaneous speed and average speed. Now we worked on all this in one of our previous lessons, but we never worked on calculations in there. In our previous lesson, we discussed the fact that instantaneous velocity is simply the velocity of a given body at an instant. Also, instantaneous acceleration is also the acceleration of a given body at an instant. So when we talk about instantaneous velocity, now since calculus really became advanced in the early 16th century, now it was possible, or it became possible, for one to be able to calculate the velocity of a given body at a given instant. So when we talk about the velocity of a given body at a given instant, or the acceleration of a given body at a given instant, now let's look at instantaneous velocity first. What is instantaneous velocity? Now, instantaneous velocity, or the velocity of a body at a given instant, is simply the limit of the average velocity of that given body as time taken approaches zero. So we're simply talking about the limit of the change in displacement. And don't forget, this are all vector quantities. Velocity is a vector quantity. Displacement also is a vector quantity, but time is not. Time is a scalar quantity. So instantaneous velocity is simply the limit of the change in displacement of a body over a change in time taken as time taken approaches zero. So we're talking about the velocity of a given body at a particular time interval. Now, this was only made possible after the development or the growth in differential calculus and probably integral calculus. So that's that for instantaneous velocity, velocity of body at a given instant. Now, what is instantaneous and speed? Now, when we talk about instantaneous or probably average, mainly instantaneous, there is nothing really like instantaneous speed, because when we talk about instantaneous, we're talking about the velocity, or I can call it the displacement of a given body at a given instant. So that demands us to get, the differentiation, you understand, of that given displacement, to the differentiation of time. But it doesn't mean we cannot have instantaneous speed. So when we talk about instantaneous speed, we are talking about the modulus of instantaneous velocity. So whatever instantaneous velocity is, we can assume, or is the same thing as instantaneous speed. So when we talk about instantaneous speed, it's simply the size of instantaneous velocity. So that's just what it is. So the next is instantaneous acceleration. Now we talk about instantaneous acceleration. It's simply the limit of average acceleration as time taken approaches zero, or we can say is the limit of change in velocity over change in time as time taken approaches zero. It's also the acceleration of a given body at a time instant. So the next we're going to be looking at will be the average. The average velocity is simply the change in displacement over change in time taken. Now, change in displacement is simply the new displacement minus initial displacement over time 2 minus time 1. So don't forget, these are all vector quantities. Okay, average acceleration. So what's average acceleration? Average acceleration is simply the change in velocity of a given body over change in time taken. So we talk about average acceleration, we're talking about the new velocity, which is the final velocity, velocity 2, minus initial velocity, which is velocity 1, over time 2 minus time 1. That's average acceleration. We did all this in our previous lesson. I'm just trying to get us refreshed on this. So the very last thing we're going to be looking at is average speed. Average speed. It was emphasized in our previous lesson, where this very stuff was treated, that there's a clear difference, a conspicuous one, between average velocity and average speed. So when we talk about average speed is simply the total distance traveled by a body over the total time taken. So more or less like saying distance 1 plus distance 2 plus distance 3 and so on and so forth over time 1 plus time 2 plus time 3. Also, it could be, provided we are given, different, what will I call it, different speed. You can just say speed 1 plus speed 2 plus speed 3, depending on the amount of speed that we have over the numbers of speed. If it's 3 speed over 3 and so on, more or less like the mean, speed or the average speed, so-called. So that's that. So the next thing we're going to be looking at a couple of calculations on all this. Okay, guys, here's the first worked example, for today's lesson. A particle moves in a straight line along the x-axis. According to the equation, x is equals to 2.00 plus 3.00t minus 1.00t squared, where x is in meters and t is in seconds. That's time. Now look at we have a couple of questions here to test how much we know this. Now the first is solve for the position of the particle at time 3 seconds. Now position simply means the distance. Now the next is find its velocity at time 3.00 seconds. The next question, find its acceleration at time 3.00 seconds. Then the next one, the fourth one, find the average speed and average velocity respectively of the particle between time 3.00 seconds and time 4 seconds. Now the very last question, find the average acceleration of the body between time 3 seconds and time 4 seconds. Now before we could solve all this, perfectly without any force, the very first thing we have to do, or we have to know, is we have to have a basic knowledge of integral calculus and differential calculus. So I'll just show us a very small example on that for us to have a little understanding of what it is. If we don't have a little understanding of what it is, there's no way we're going to be able to solve all this. So now let's look at what differential calculus and integral calculus simply are. So we'll talk about y. Let's say y equals to 3x squared, for example, and they want us to get the y dx. They want us to differentiate. They want us to get the y dx or the slope. So what is the y dx? That's a simple method. It's a direct method according to the first principle. There's a simple method we could use, a simple approach. It's very simple. We just take the power, use it to multiply the coefficient here, then we subtract 1 from the power. So the y dx, that is change in y, that is uppercase delta, change in y over change in x, is equals to this. The power here multiplies all this, then subtract 1 from the power. So 2 times 3x squared, then take 1 away from the power. This is a simple direct method. So that will be 2 times 3 x is power 1. That is 2 times 3 is 6x. So whatever it is, even though it's y equals to 3x is power 3, either positive or negative, just take the power. If it's y equal to 3x power 3, just 3 times 3x is power 3 minus 1. So whatever it is, just take the power, use the power to multiply what you have, then take 1 away from the power. As simple as that. So this is the y dx equals to 6x. These are the differentiate. These are just the basics. So it means the y dx, it means the y it's equal to 6x dx. So now integration helps us to reverse what differentiation has done. So integration is the reverse of differentiation. So when we try to integrate this, let's integrate this. We have our integral, the y equals to integral 6s dx. Now when you have an integral like this, it is ordinary y. When you integrate the y, it's ordinary y. When you integrate the s, it's ordinary s. So integral the y is equal to y equals to integral 6x dx. Now how do we integrate? Integration is the opposite of differentiation. So everything we do while differentiating, we're going to do the reverse of it, no while integrating. Now look at what we did here while we are differentiating. We took the power, we multiplied first, and after that we subtracted 1 from the power. So what we're going to do, we're going to have a reverse. Now it's going to be, we're going to add to the power. Now after adding to the power, instead of multiplying, then we divide. We add to the power, then we divide. So what do we have? This is 6x raised to power 1. So what do we do here? We add to the power plus 1. So what do we have? We have 6x squared. Now after we've had this, the next thing that we are going to divide by the power. What power do we have here? 2. So divide with 2. So 2 here 1, 2 here 3. What do we have? 3s squared and plus a constant c. So we have our 3s squared already. We have it back. So you have it already. So already reversed. As simple as that. So we need to understand this very phenomenon before we can understand the major questions given to us. So now let's go back to our question. Now the very first question, we are asked to solve for the position of the particle at time 3 seconds. Now don't forget we are given an equation. This is a positional equation. X equals to 2.00 plus 3t minus 1.00t squared. So let's take that down. X is equals to 2.00 plus 3.00t minus 1.00t squared. Now look at this. For the fact that this body moved in a straight line, Now, each time we talk about instantaneous, whatever kind of instantaneous, either instantaneous velocity or acceleration, each time we discuss this, what we mainly deal with displacement and velocity and acceleration. We don't really talk about distance. We don't really talk about speed, because what we're talking about here, demands perfect direction, change in, perfect direction, change in stuffs, and so we don't really talk about displacement, distance, I beg your pardon, and speed. But since this body moved in a straight line, it means this could be displacement, and also it could be distance. That's what it means. So now look at the first question. The first question there is for us to get the position of the body at time 3 seconds. So how do we get the position of the body at time 3 seconds? Now the position could be displacement and could also be distance, because we are talking about this body moving in a straight line. So the body is not moving from one spot to another spot, reversing and going back and forth. If it does that, then we're not talking about distance. But since the body moves in a straight line, we're talking about displacement. So time is 3 seconds. What do? What is the position? That will be s equals to 2.00. We just substitute the t equal to 3 seconds into what we have here, plus 3.00 times time. Time is 3.00 seconds. Then minus 1.00 times 3.00 seconds raised to the power of 2. So we're almost there. It's very simple. We're almost there. So what do we have there? That's 2.00 plus 3 times 3 is 9. 0.00. That minus 3 raised by 2 is 9. 9 times 1 is 9. 9.00. So what do we have? This can take out this. So the displacement or the distance is simply 2 meters. As simple as ABC. Okay, question 2. Now, since the equation of the whole movement is x equals to 2.00 plus 3.00t minus 1.00t squared. Now, we are asked to get the velocity of this very particle that moved at this very equation at time 3.00 seconds. Now, how do we do this? Now, don't forget what we have right here is either displacement or distance equals to this plus this, all the stuff here, they're all right in time. So this time squared, this time raised by 1, this time raised by 0. Well, right here we have a distance or displacement. So how do we get the velocity? How do we get the velocity is very, very important, and that's why the knowledge of differential calculus, is very needed. It's very needed here. So now the only way we can get this done is differentiating. We have to differentiate first. We have to differentiate to get the velocity before we can then get the velocity at time 3.00 seconds. Now it's going to be very funny if you try to substitute this in. If you put in your t, into this very equation to get your distance, and then you try to do distance by time taken, it doesn't make any sense. That's not the way to go about it. So first thing you have to do is to differentiate. So let's differentiate. Calculus comes in handy here. So if x equals to 2.00 plus 3.00t minus 1.00, then time squared. So if you differentiate the x over the t, that is, if we differentiate displacement over time, we're going to get the speed or the velocity we're talking about, velocity along the x-axis. We call it instantaneous. This is what we call instantaneous velocity. Now, sometimes it's not a must that will tell us find is instantaneous velocity. We know that it's instantaneous velocity because it's the velocity at that time instant of 3 seconds. So velocity, now let's differentiate. Now this is t raised to power 2, t raised to power 1. This t raised to power 0. Don't forget the way we said differentiation, is being done. We take the power, we used to multiply this, you take 1 away from it. So that is 0 times 2.00. t raised to power 0 minus 1. Then plus, we'll take 1, you used to multiply, then take 1 away from this. 1 times 3.00. t raised to power 1 minus 1. Then minus 2 multiplies this, you take 1 away from 2. So that's 2 times 1.00 t raised by 2 minus 1. So we're almost there. So the x, the t is, this takes out the 0 times this, they're all gone. The 1 times 3, 3 raised by 1 is, 3 raised by 1 minus 1 is 0, 3 raised by 0 is 1. So what we have left there is just ordinary 3.00. Minus 2 minus 1 is 1. So that's 3 raised by 1, 2 times 1, that's 2t. That's what we have. This is the velocity of this very body. So now, what is the velocity at time 3 seconds? So the velocity at time 3 seconds is going to be, at that time instant, is going to be 3.00 minus 2 times 3.00 seconds. So that would be 3.00 minus 2 times 3 is 6. So what do we have? That's minus 3 meter per second. So the body lost some speed. That's what it means, body lost some speed. So as simple as that, that's that for question 2. Okay, question 3. Now we are asked to get the acceleration of the very particle at time 3 seconds. Now, how do we get the acceleration of this very particle at time 3 seconds? Now, it's very doable. Don't forget the equation that we have right up there. We have displacement equals to 2.00 plus 3.00 t minus 1.00 t squared. Now, from that very equation, we're able to get our velocity, to be 3.00 minus 2t. So what you just have to do now is we're going to differentiate again. That's what we're going to do. Since velocity at that very given time instant is 3.00 minus 2t, like this, and we are asked to get the acceleration of the very given particle at time 3.00 second. So what we're going to do now is to differentiate again. Now, when we differentiate again, that will be change in velocity of a change in time taken, which will be equal to acceleration. So that's the v, the t, will give us acceleration. So we're going to differentiate. We have the v, the t. Now, don't be tempted to put in your value. Don't put your time 3 seconds into this, thinking that when you get the velocity, then you do the velocity about time. No, that's not the way to go about that. It's not the way to go about it. So what you just have to do is to differentiate to get the acceleration. So this is more or less like saying instantaneous acceleration of this body, instantaneous acceleration. So how do we do this? So dv dt will give us acceleration at this very given instant. So we're going to differentiate this t raised by 0, this t raised by 1. So we have t raised by 0. When this 0 times this minus this goes out. So what we have here 1 times. So that is minus 2 times 1, and t raised by 1 minus 1. So 1 will multiply this and take 1 away from this. So what do we have? That is 1 minus 1 is 0. So t raised by 0 is 1. So what we have here is minus 2. So you have minus 2 meter per second squared. So if this is minus 2 meter per second squared, so don't forget this minus 2, t raised by 0. Let me just say that. So that's the acceleration at the given time interval. So the t at t now, which is 3 seconds, there's no point because it's going to be 3 raised by 0. So acceleration at this time interval, 3 seconds interval, is minus 2 meter per second squared. So the body was decelerating. It's easy as that. So here's a penultimate example, worked example for today. Now we're asked to get the average velocity and average speed, respectively, of the particle between time 3.00 second and time 4.00 second. So we're asked to get the average velocity and average speed. Now don't forget there's a clear difference between average velocity and average speed. They're not the same thing. They're very different. There's a clear difference between them. And don't forget for average velocity, it is change in displacement over change in time taken. That is new displacement minus initial displacement over new time minus initial time. Why average and speed is total displacement or total distance traveled over total time, taken to cover those distances. So now we're going to be needing our equation given up there. So x, which is either displacement because of the body traveling in a straight line, either displacement or distance. So s is 2.00 plus 3.00 t, the minus 1.00 t squared. This is the equation we've been working on. So now, how do we get the average velocity? How do we get average velocity? Don't forget, average velocity, very well known, is change in displacement over change in time taken. So displacement 2 minus displacement 1 over time 2 minus time 1. So first of all, let's get our first displacement. So at first time, at time 1, which is 3.00 second, so it means our displacement, which is displacement 1, will be 2.00 plus 3.00. So time 1 is 3 seconds, 3.00 seconds, minus 1.00. Then time 2, time 1 I mean, is still 3.00 seconds raised to power 2. So you see on the first displacement, so that's 2 point, you just have to substitute in for this. So we're going to get the two displacement, get our two time taken already given. Then from there, we just bring them together to get our average velocity. So what do you have here? This 2.00 then plus 3 seconds times 3 times 3 gives us 9, 9.00. Then minus 3 raised by 2 is 9, 9 times 1 is 9. So we have our first the displacement to be 2, we got that earlier, 2 meter, that's our first displacement. So quickly, we're going to fix in the second time to get our second displacement. That's what we're going to do next. So at time 2 is 4 seconds. So if time 2 is 4 seconds, then displacement 2 is going to be, just fix it in, I mean, so 2.0, 0 plus 3.00 times time, 4 seconds, minus 1.00, time 4 seconds raised to power 2. So what do we have? So displacement 2 then will be 2.00 plus 3 times 4 is 12. 4 raised by 2 is 16. 16 times 1 is 16. So we have that. 2 plus 12 is 14. 14 minus 16 will give us minus 2.00 meter. That's what we have. So we have our displacement 2 and our displacement 1. So what is the average velocity? What's the average velocity? Now the average velocity is here. It's very simple. Then look at the question. Look at the formula. Displacement 2 minus displacement 1 over time 2 minus time 1. So what's displacement 2 minus 2.00 meter minus displacement 1, 2.00 meter over time 2. What's the time? Second time is 4 seconds minus time 1, 3 seconds. So what do we have? Minus 2 minus 3 is minus 4. 4 minus 3 is 1. So what do we have here? Minus 4.00 meter per second. As easy as that. So the next thing we're going to get now is we're going to get our average speed. Now don't forget this is average velocity. For average velocity, change in displacement over change in time taken. But for average speed, don't forget for average speed it is total displacement or total distance, I beg your pardon, over total time taken. So we can also assume that these are distances because the body traveled in a straight line. So how do we get the total, how do we get, we're going to get the total distance. So that's going to be minus 2.00 meter, distance 1, plus second distance 2 meter over total time taken. Total time taken, first 3 seconds, next 4 seconds. So that's 3.00 seconds plus 4 seconds. So when this come together, they will take out each other. That's 0 meter over 7 seconds, which is 0 meter per second. So the average speed is 0 meter per second. As easy as that. Okay, guys. Here's the last worked example under question 1. So find the average acceleration of the body between time 3.00 seconds and time 4.00 seconds. Now we are asked to get the average acceleration of the body between this two set of time. Now the displacement, this was a major equation we're given, from the very beginning of this very lesson. Displacement as s equals to 2.00 plus 3.00 t minus 1.00 t squared. And from there we were able to differentiate it to get our velocity out of their given time instant to be 3.00 and minus 3.00 minus 2.00 t. Now, for us to get the average acceleration, we all know the formula for average acceleration. Average acceleration is simply this: acceleration average is simply change in velocity over change in time taken. So it's very, very important that we have our velocity. So we're going to be using this for us to get the average acceleration. So at this 2 time interval, at time 1, let's get our velocity at time 1. We're going to substitute this into this our very derived equation. At time 1, velocity 1 would be 3.00 minus 2, 3.00. So what do we have? That's 3.00 minus 2 times 3 is 6. So at time 1, velocity 1 is minus 3 meter per second. That's the first velocity at time 1. So right away at time 2 is 4 seconds. At time 2, which is 4 seconds, then velocity 2 would be 3.00 minus 2. Then 4, that's 4.00. That's the time. So that's 3.00 minus 8.00. So velocity 2 at time 2, which is 4 seconds, is minus 5 meter per second. That's what we have. Velocity 1 minus 3 meter per second. Velocity 2 minus 5 meter per second. So we are set. So how do we get the average acceleration right now? Average acceleration is very simple. We can get it. We have all our parameters ready. So change in velocity is velocity 2 minus velocity 1. That is final velocity minus initial velocity over time 2 minus time 1. So what do we have there? That's minus 5 meter per second minus 3 meter per second over time 2. The second time is 4 seconds minus time 1, 3 seconds. So what do we have? Average acceleration is minus 5 minus 3. So that's minus 5 minus 3 minus 5 plus 3 over 1. What do we have there? Minus 2 meter per second squared. As simple as that. So that's everything for the very first set of examples. So you're going to be looking at the second example to round off today's class. Question 2 and the sub questions will aid us round off today's lesson on a high note. So look at this. A body moves in a straight line along the x-axis with a speed of, now look at the equation given to us, with a speed of that velocity at this very given time, this instantaneous velocity, 15t squared plus 6t minus 4 at a given time instant. Now we are given two questions. So first, solve for the position, that is the displacement or the distance of the body at time 2 seconds. Then the next, solve for the average velocity and average speed of the body between time 1 second and time 2 seconds. Now, how do we go about this? Now, as you can see, right here, we've been given the instantaneous velocity, some 15t squared plus 6t minus 4. And now we are asked to get the distance or the displacement of the very given body at time 2 seconds, since the body moved in a straight line. So how do we do this? The knowledge of integral calculus will come in here to help us out. So, so that v at this very given time instant is 15t squared plus 6t minus 4. Now this is given. So the next is you're going to differentiate. You're going to integrate. I beg your pardon, to get our displacement. So you're going to do that. So how do we do that? So we're going to integrate this. Integrate the v. So when we integrate, don't forget that we said integration is the absolute reverse of differentiation. So what we're going to do first, we're going to add 1 to the power. So whatever we get from there, we use it to divide. Like that, we're going to do that repeatedly until we're done. So what do we have? This 15t squared plus 1 over 2 plus 1 is 3. So divided by 3 plus the 6t raised to power 1. We add 1 to it. 1 plus 1 is 2. Divided by 2. So this minus 4, this t raised to power 0. We add 1 to it. 0 plus 1 is 1. Divided by 1. So we write on this. We're almost there. So what do we have? So we're going to have this. We're going to have a distance right now. Distance at this given time. So 3 here 1, 3 here 5. So that's 5t cubed plus 2 here 1, 2 here 3. 3t squared minus 4t. So that's what we have. Finally got in our displacement or distance because the body moved in a straight line. So this was what we had that was differentiated for us to get this. So how do we solve for the position of the body at time 2 seconds? So the position of this body at time 2 seconds will be 5 times 2 to raise to power 3 plus 3 times 2 to raise to power 2 minus 4 times 2. So 2 raised to power 3 is 8, 8 times 5 is 40, plus 3 raised to power 2 is 4, 4 times 3, 12, 4 times 2 is 8. So the position, 12 minus 8 is 4, 4 plus 4 is 44. So it's 44 meter. The body was at the very distance, 44 meter at time 2 seconds. So the body was 44 meter at time 2 seconds. As simple as that. So quickly, let's look at the second one. Second one, we're going to solve for the average velocity and average speed of the body. Now, for us to get the average velocity, don't forget Average velocity is simply changing displacement of a change in time taken. So we have to do that at 2 time interval, time 1 second and time 2 seconds. So we have our this already. We have displacement here already as this. So we're just going to get the displacement 1, displacement 2, for the 2 different time intervals given to us. So first of all, time 1. At time 1 second, what's going to be the displacement? So the displacement 1 would be 5 times 1 raised by 3 plus 3 1 raised by 2 minus 4 times 1. That's what we have. So displacement 1 raised by 3 is 1 times 5 is 5 plus 1 raised by 2 is 1 times 3 3 minus 4. 5 plus 3 8 minus 4 is 4. There's 4 meter displacement. Then at time 2 which is 2 seconds. So the new displacement would be 5 2 raised by 3 plus 3 2 raised by 2 minus 4 times 2. So 2 raised by 3 is 8. 8 times 5 is 40. 2 raised by 2 is 4. 4 times 3 is 12 minus 8. So 12 minus 8 is 4. 4 plus this is 44, 44 meter. We have this already. So what's now the average, what's going to be the average velocity? So average velocity right now, average velocity would be changing displacement of a change in time taken. So displacement, change in displacement, displacement 2 minus displacement 1. That's what we're about to do. So the displacement 2, which is 44 meter, minus displacement 1, which is 4 meter, over time 2. Time 2 is 2 seconds, minus time 1 second. So what do we have? This 40 meter over 1 second. So average velocity is 40 meter per second, as easy as ABC. So the next we're going to do right now is we're going to solve for the very last step, which is the average speed. So the average speed, how do we get the average speed? Don't forget total distance over total time taken. Total distance over total time taken. So what's total distance? 44 meter plus 4 meter over 2 seconds plus 1 second. Now I want to know something. It's not really like displacement and distance are the same thing. We said it earlier on that the reason why we can use this quite interchangeably is because of the fact that the body moved in the straight line. The body did not go back and forth. So for the fact that the body goes in the straight line, it means this. If this is displacement, then equals to be distance. So 44 meter plus 4 meter over 2 seconds plus 1 second, that will give us 48 meter over 3 seconds. So we're good. So what's next? The average velocity is 3a1, 3a 16. So 16 meter per second. So that's that for today's lesson. So the next is our take home to see how much we got from today's lesson. Okay, guys, it's time to get ourselves tested with a couple of questions as a take home. So here's the first question. An object moves along the x-axis in a straight line. According to the equation, x equals to 3.00 t squared minus 2.00 t plus 3.00, where x is in meters and t is in seconds. Solve. Now look at the very first thing you're going to solve for. Solve for the average speed and average velocity of the object between time 2 seconds and time 3 seconds. So question 2, solve for the instantaneous speed or instantaneous velocity. Now instantaneous speed is equals to the size of instantaneous velocity. So instantaneous speed is the same thing as instantaneous velocity at time 2 seconds and time 3 seconds. So the very next question, solve for the average acceleration between time 2 seconds and time 3 seconds. Then second to the last, solve for the instantaneous acceleration at time 2 seconds and time 3 seconds. So the very last question for question 1 is solve for the time at which the object is at rest. At what time is the body at rest? So that's after that. So the next set of questions, a body travels with an acceleration, now look at the question, of minus 12t squared plus 4t plus 3 at a given time instant. Now we asked to solve for the velocity of the body at time 4 seconds. We also asked to solve for the average acceleration of the body between time 3 seconds and time 5 seconds. So here are all the questions to get us tested to see how much we got for today's lessons. If you found today's lesson very resourceful, please subscribe to this very channel and share this lesson with others. See you in the next lesson. Thanks.